Assalamu alaikum, welcome to my channel. Today we're going to discuss about a data structure stack in C++. Stacks work on the mechanism of last in first out, or we can say first in last out. It means that the element that has been inserted very first will be retrieved at the last, or the element that has been inserted at last will retrieve first. For example, if I have these element 1 2 3 like 1 2 3 4 5, I have inserted in them in the order like first the 5 was inserted, then 4 3 2 1. So now the 1 will be retrieved first, or I can say the 5 which has been inserted first, it will retrieve at the last. So the functionalities which I'm going to implement is the push function, and then the top function, pop, empty, full, copy constructors, and the assignment operator are equal to operator, and the destructor. So these are the functionalities I'm going to implement, and this stack is going to be linked list based. I want it to be aligned with the stack available in STL, standard template library. So I will. So first of all, I will take a structure of node, and in this we are going to take two parts. First one will be, let me take it as a template. So I want my stack to be generic. That's why I'm taking template. So there will be a data part of generic type T, and then we have a next pointer of the same node. This is how our linked list worked. Linked list, like it has a list which contain two parts, the data part and then the next part. The next part point to the very same node of that, which also contains the data part and then the next part, and this list goes on and on. The next part keeps a link to the very next part, and then the last part has nothing in its next part. So now it's a very good practice to have a copy constructor in it. That's optional. If you don't want to have it, it's your choice. So first one will be value, and I can't assign them any kind of value here, but for node next part I can assign it to null, because in case I don't want to pass any value, the default value is null. So now the assigning part is like data will have the value and the next part will have the end part. So this is it for our node structure. This is for the linked list we want to establish, and then now we will move on to our stack class, and I will make that stack class as templated as well. So I hope you know about the templates, this class, and everything. I have a video on this, you can go and watch this. So now and the only data member I will have here is like head, or you can name it any type, but this will be of this node type. So a pointer to this node, I will take a pointer to this node will be of which will be of generic type, and I will name it as head. And this is the only data member which I'm going to have in my stack class. This is why, because the head will always keep pointing to the very top element. For example, in our case, the head will keep pointing to 1, and these functionalities I would like to define them now. The push function will push the element in the stack. For example, if I want to push 0, then it will push 0, and it will come before this before these existing elements like this whole list. The 0 will come at the top. And if I want to access the top element, then I will use the top function. Top function will always be pointing to the very top element, and then the pop function will remove the very top element in our stack. For example, if I call a top function, then 0 will be removed, then the top will be pointing to 1, because 0 is moved and 1 is now on the top. So empty function checks for the list, the stack is empty or not. The full function checks for is whether the stack is, in our case, the if the heap gets full, then the full function will return true. Otherwise, it's a rare case that the heap gets full. So then the copy constructor, if we want to create another object which has the same data of the first object, then the assignment operator works similar to the copy constructor. Just there's a little difference I will tell you later. And then the destructor is an important part which frees all the memory. In destructor part, we will free all the memory we have allocated on the heap. So now coming back, we have a single head pointer, and then in the stack I will just stack constructor, I will just uh, make the head equal null. This is an indicator that when the object of this stack class is created, then there will be no element in the stack. The head is null, mean there is no element in the stack. So then I will implement the push function. So it will take a single parameter will be of generic type, and I will like to take it as reference. So this has been kept constant because I don't want this value to be changed inside my function. So now the very first element being pushed into stack is going to be the very last element. If I draw a sketch here, then and just keep looking that if I insert the first element, just assume this is the first element inserted in the stack. Then if I insert any other element, then the next element which comes after will be on the top of the element present before in my stack. So in linked list case, the linked list has two part, the data part and the next part. So for the very first element there, which is going to be the very last element in our stack. So for this, the next part will be null. There will be no next part. This part will be null. Sorry for my bad handwriting, but this part will be null. The new upcoming element will be on the top of this. Mean there will be like if there is going to be a second element, then this part will have a link to this part. For this is the variable top pointer. This is our top value, mean the value that has been inserted at the very last point, and then this value has was inserted before this last element. So this is on the end and this is on the top. So for this there will be no next part, but for this has the link to the existing element in our stack. So coming back to our implementation, so for now, I will just create a temporary pointer now, a temporary pointer which will hold our the data part as well as the. So I will just allocate it to memory on the heap, and then like so I have created my constructor. So I will just call my constructor here. The use of constructor is quite um, easy to use. It's become very easy here. I don't have to just get the I don't have to just do like the data part equal the I don't have to use this arrow operator to get to the data part to assign values. I don't have to do this. I will just use the constructor. So it's a kind of ease for me. So for now, I have told you the very first element is going to be the last element, but the data part for every upcoming value will be the same. So I will just keep on passing the data part in my temporary pointer, and then in the next part, I have to pass the null for the very first value. So if you look at this head now, the head at the very start, whenever object is created, when there is no element in our stack, the head is null. So if I pass the head here, then this element, the very first inserted element, will have the null value. The head is pointing null, so the null value will be assigned to this list. But the list type of structure which this will have the value part. Like you can see that the value part has been assigned and the next part has been allocated null. So this was like a temporary pointer. This has only the scope until my uh, until this function is not ended. So I will do what? I will just assign the head this temporary pointer. So now what I have done that I have created a node like this or a node. This has the value and the next part is null. This was first a temporary pointer, but then I assigned the head equal this part. In this way, my the data member which will never dies, which will dies when the when our stack destructor is called, this head will die then. So head is now pointing to the very top element in our stack. So now assume this is going to be the same lines for the second element being inserted in our stack as well. You must have seen before that people like to, if head is null, then there is no, then write some code and then the else part and blah blah. So for now, let's assume the second element comes in. The second element temporary pointer has the element second element, and then in the next part it has the head. Head was pointing to the very top element, which was our first element in our stack. So now the second element has the link in its next part to the very first element inserted in our stack. So then I just moved the head to that temporary. The head was pointing to the very first element inserted. Now the head is pointing toward the second element being inserted in my stack. So in this way, the upcoming values, you can see that the values now, if third value comes in, fourth comes in, the head is keep pointing to the very. So the our push function is done here. The next thing I'm going to implement is the top function. So top function will just it's going to be constant, because we don't want any kind of change in any kind of value change in our top function. So what it will do, it will just return the very the data part of the head pointer, mean the top value present in our stack. It will return that. Then coming up to the pop function. In pop function, I will just I want to move head from the first part to the second part in our stack. So it's not like that. I've just write like head equal to head like next part, and head like move to the second part. I have to free the memory as well being allocated. So what I will do, I will just create a temporary pointer, and I will assign it head. So now I will just move the head to the very next part of the head. So now I will just delete, if I just delete the temp, then there is no then so now we have like freed the memory as well, which has been allocated to the node using our free new pointer. The memory has been freed up and the head pointer has been moved to the very next part as well. It's like that we were here in the head, and then I have moved the head to this part, and the temporary pointer that was pointing to this part, that got deleted. So the memory for this part has been released, as well as the head has moved to the second part. So now coming up to our other functions like full and empty. So now full for full, we will just allocate the memory on the heap, like so. I have done like this. If I just copy paste this, so I will just check now if if the temp will return true only if the uh, value has been allocated on the heap. As if the value has been allocated on the heap, then it will return true, otherwise it will return false. So if our memory is allocated on the heap, then the function is not, then our heap is not full, so we have to return false in this case, else we will return true. Because if the memory is not allocated, then the stack is full, then we have returned the full. So now for our empty function, we will check if the head is null. If head equal null, then there will be no element in our return true, else returns false. So this was very much it for our full and empty. So we can check this condition in here as well. For example, if full, then we can throw an exception, like throw exception that stack overflow. It means that the stack has been overflowed by the number of elements inserted, and then in the pop, if we call the empty function, if empty, we can throw the exception like the stack underflow. It's quite similar if we were dealing with the arrays. It's like the out of bound, and it's also like the index out of bound because we are not in the range of the value that we have specified. So the functions, we will implement the destructor part first. So in the structure, I will just write a simple statement like while not empty, keep on calling the pop function. So now this will do like, this will first check if the stack is, while stack is not empty, sorry. So while the stack is not empty, keep on calling the pop function. Pop function is going to remove every single element in our stack. So then at the end, I will just implement the copy constructor and the assignment operator. So for the copy constructor, I have to write like constant the object of the same class and the object. So in copy constructor, we will just made a copy of the same existing object. In case the copy constructor called, then the default, then the default constructor or any other parameterized constructor will not call. The rule is when the only one of the three constructor can be called. For example, if I create an object, either the default constructor is going to call parameterize or the copy constructor. In our case, in the case the copy constructor get called, then the default constructor will not get called, mean this statement will not execute, but we want this statement to be executed. So we will just write this first line in our copy constructor. Then the logic is that if I just assign the values from copying this object to directly to the new stack, then it will just reverse the order. For example, if I have order like 1, 2, and 3, and I've just pushed the element straight away into the next stack, then I will like I'm going to have an error like 2, 3, 1. So in order to avoid this, I will use another stack as well. First of all, I will just create a node pointer h, which will be on pointing to the head part. So now I will just create an object of the stack s, and while not while h is not equal to null, keep on pushing the stuff of head data into that stack, and then move the head to its next part, h2, the very next part. So now what I have done here, I have just created another stack object. I have pushed all the elements present in our the past object into this stack. So now I will just simply write like why not that as empty. I will just keep on pushing the element of that stack to in my original stack. So after that, I have to call the push as well. So the thing have been which has been done in here is the object passed on the object, all the value of the object data has been inserted into a copy of the stack, and then that copy has been inserted in my original stack. So for assignment operator, I will just also takes in a stack object by reference. So stack object, the code will be in the very same, but rather I will do is that I will just copy this code and paste it up here. In assignment operator, when the assignment operator is called, the default constructor has been called initially before the calling of this assignment operator, so we don't have to write this statement. So I have just rewrite the code, but instead we can do like, I will just call the operator equal to here and then pass on the object here. So what this will do is when the copy constructor is called, this will just initialize that statement, which is very necessary because the other constructor are not being called. So it will just initialize that statement, and then the assignment operator will do all the rest of the work. So it's quite similar. It's better than rewriting the code. So this is it for our stack class. So now I will just create a stack object of integer type, and I'm going to call it s. So I will just keep on pushing the values in it. So if I just keep on copying this, we have not handled the duplication. So if I keep on writing like 10 10 10, then it won't give me an error. So I will just use a loop while I start not empty. uh, just print for me the very top value, so our top function, and then next statement will be like calling the pop function but by the reference of that object. So hopefully I will get like, so there is some error. uh, this error is because of this node. um, so I missed the brackets here. The default constructor has not been provided, so I will go on and provide like the default constructor, so in order this statement get executed. So all good. This will get executed now. So hopefully I will get the values like 30, 20, and 10. Xcode is a bit slow. I use it because it's the only IDE, the professional IDE present in the Mac. But instead I have the Visual Studio Code as well, but I don't use that because it's not like a proper IDE for C++. So our desired output has been shown in our case. So now I will just create a copy of my stack class for integer as well, and I'll call it like s2, and I will assign it s2. In this case, the copy constructor will get called. In this case or neither this case. These are two cases when the copy constructor get called. So I will just while not s2.empty and then s2 and then s2. So I will like write a cout and L as well, and a line, because I want these two output to get or distinguish from each other. So for these, there must have been some mistake. So head is not equal to null, head data push. So there was a little mistake. We have to call this pop function with the reference of this stack object, because we don't want uh, to, we want our value to be erased for this object. So all good now. We will rerun the code, and our output should have been, well, this was the one problem, but the other problem was that we have just empty our stack. These statements, this pop statement has vanished out all the element present in our stack. So instead I will just assign it before the the empty of this stack first stack object. So now I have just got the output the same as the first one. So I will just provide the link of GitHub, my GitHub account, where this repository for the stack code will available. You can go and check out this code. So this was it for the video. In the next video, hopefully I'm going to implement the same data structure stack queue for C++. So stay tuned. Allah Hafiz.